Our next discussion is about the space-time continuum.
Hi, my name is Dr. Mesut Dinson. I am my friends.
Frank Genovese.
John Streeter.
Kara Mahler.
And George Tunkel.
Today we would like to talk about space-time continuum. There is a lot to say about space-time continuum. What we knew of time and space have changed within the past 100 years, and maybe everything, all the technology that we have, some of it we may be owing to understanding of these concepts. Although at one time space was very static place that was considered by the scientists, within past 100 years with the theory of relativity, we know for a fact space-time is a dimension that is not flexible, not static, flexible, and changes based upon the speed of light. And I would like to have some input from my friends who are willing to eagerly, proudly would like to give me their input.
Well, my big thing that I thought about when I think about the space-time continuum is something I heard about recently, and that's brain theory. And kind of getting back to the origin of the universe, the origin of space-time, is that the concept is that there are energy planes or dimensions that are 1/trillionth of a nanometer away from each other, and they sit there in all time and space, and they come together in specific locations momentarily, creating a big bang, thus creating a space-time continuum within that specific brain and a reflection in the opposite brain. So that was kind of a new thing that I had looked at as far as space-time. So where did it come from? Where does it originate from? And that it's basically just a large vibratory explosion expanding out in space. So a lot of people think of space-time continuum as like just space-time, how we move through space and time, but I'm starting to look at where did it come from? Why does
Big
it
Bang.
exist?
Before Big Bang, supposedly there's not supposed to be anything. We cannot talk about anything. But when Big Bang explosion happened, we're talking about the mass, energy, like you can measure mass. You have a volume. You can talk about some properties of the existing entity, but there is no time, there is no space before that. So the way I kind of feel is when the Big Bang, after Big Bang occurred, time and space also came along with that. Now, as far as the time, there are different, theories, different people in different things, but it's very difficult concept, and with theory of relativity, it needs to be looked with space-time continuum. But I always kind of look at the time itself as, is the time property of matter, just like mass? Is the matter as some energy force that reflects time, and based upon how much of such a force there is, maybe where there is gravity versus where there is no gravity, there's a difference. That's what makes the why time slows down when you at a different altitude. So.
My opinion is that we have poor definitions of space and time. So I don't think we have a really good definition of either at this time, pun intended. But it is my feeling that when I think of space, I think of a quantity or an entity or an idea that involves dimensionality. When I think of time, I think of a process that occurs, whether it's a forward or backward direction, as a result of various properties of matter. When I think of space-time continuum, I like to think of, I think of a clock that's connected by a ruler, that's connected by another clock, that's connected by a ruler, and if you put this in a dimensionality aspect and form 3D, you have an X, Y, and Z plane. At each vertex you have a clock. And of course the ruler represents space in its three-dimensional form. And when I think and conceptualize space-time continuum as such, that is also influenced by the speed of this square, so to speak, moving through the time element or the time aspect. We all know that Einstein, his probably crowning achievement with regular general relativity was the space-time and the effects of gravity as such. He, of course, now akin to a rubber sheet that had anything with a mass in it would deform or deflect that sheet was on a singular plane. I think that is probably by far and away the best working definition of space-time and space-time continuum that we have to date. I think that when you add the submicroscopic or the quantum realm to that space-time continuum, it will bring out another aspect that I don't think any of us are very, we don't understand or are comfortable with at this point. But so from a theoretical space-time continuum, I believe that they are connected. I do believe that time adds another dimensionality to space, but by the same token, just continuum and directly connected. As Dr. Dinsa pointed out earlier with the Big Bang, you can't talk about anything before the Big Bang because you could theorize, but you can't really know anything about it because that is when space-time continuum started. And I believe that it is part of why we have trouble with the time element. I think when we talk about the hour of time and time going forward, so to speak, it is because of what happened at the Big Bang. I think when that singularity or the Big Bang event occurred, it occurred with a directionality or a vector force going in one direction, or if you will, in many different directions outwards from that singularity, and hence the hour of time and why things flow and why things are the way they are. Again, as I had mentioned earlier in physics, there's nothing to suggest that time is one way or flows in one way, other than the fact that there was a singularity and a Big Bang event. That, by definition, will cause time to occur and flow in one direction, and I believe that's what we're most comfortable with, what I'm most comfortable with thinking about the flow of time, so to speak. But I believe that's an incomplete idea of time.
Speaking of space, at one time scientists used to think space as just a empty, something empty. No matter is there. But with Einstein theory of relativity, things have changed. Now space is there. Space does exist. As a matter of fact, with the theories and one of the reasons why the Hadron Collider exists, to try to prove some of the theories put forward about Higgs Boson theory, that actually a space as there's a mass there that we may not see. Maybe it's small enough to be not to be to have a mass, yet not to be affecting the any atomic mass that we know of, larger size. so be able to perhaps even pass through space. We are maybe passing through different dimensions, perhaps the existing energy matter complex far maybe smaller than we are aware of. So in other words, I am trying to say one way to look at the dimensions maybe it's a level of matter energy complexes, the size wise, and they're able to relatively much smaller than the other, the larger one able to go through the smaller one, but yet that small one could be even a larger one to even smaller one, and so that may go on quite a bit in a maybe not necessarily infinite number, but it will go on quite a bit where you see quantum world on one end, on the other end you see the galaxies, you see the universe as we know of.
I have two things in regards to space and time, and I've talked to you about this before, is you look up in space and you see the past, because you're seeing stars from light from how many thousands light years away. Like I said, those stars may not be there, but the light is reaching us in the present time. And the other thing is, when you say 13.7 billion years ago, the Big Bang happened, have we humanized the year, though? Our year is 365 days, because that's how long it takes us to go around the sun. We've created this 13.7 billion light years because we're saying light travels at a certain amount of speed per second times how many days for 365 days, 1 light year in our light year is this distance. So that's the other thing is have we humanized our 1 year because we're
actually the 13 point is a billion years is a humanized time,
right?
But as far as the size of the universe, radius, that's been addressed as a light year. I don't know the exact number. If any one of you could tell me.
What's that?
The size of the universe in light years now.
Be a very large number.
Yes.
No, it's not large number. It's with the light year, but it's not a maybe it's not a the large number because you tend to do whatever you may be using, but it's even 13.5 billion years. It's not a whole lot.
Well, it's an easy calculation. If you say that life travels 182,262 miles per second, or a little over a trillion miles in a year, and then you multiply it by 13.7 billion, you get the radius of you get the diameter of the universe. Mm-hmm. So in and of itself, that's the number you're probably looking for. Mm-hmm. But the point is that we have to realize that is our best guesstimate of the age of the universe. But
with our capacity,
if you think, and I like to think about, it was Hubble, by the way, in what was it, the early 30s?
Yes,
when,
late 20s, something.
Late 20s, early 30s, when he looked up and saw that there was the red shift, and that the universe was in fact expanding. And now we're finding out that not only is it expanding, it's
speeding
expanding up. It's speeding up, exactly. And and when I think of space-time, I like to think of, if you start with a very, very tiny deflated balloon and you suddenly inflate it and blow into the balloon, and you put sequential dots on the surface of the balloon, each dot is expanding away from each other at an exponential rate. And it's not like there was a pre-existing space per se, but the space itself is expanding through what? What is it expanding through? But I think that's a moot point. It's really not what is it
through
expanding.
time.
It's not what it's expanding through. It's not expanding through time. I think it's expanding with time, by the way. So it's really a conceptual idea, I think, that is just absolutely fascinating.
So what about the concept of the universe is speeding up? If we look at an orb, a glass ball, so if the universe started out at a single point and the light and energy is traveling on the outside of the orb, once it gets to a certain point, it'll appear as though it's going faster, but to be actually going back to the original point that it started from. So is the universe really a big donut in space-time, where light and energy have traveled around a big circle? They start at a single point, and they recycle over and over and over. So that kind of gets back to the beginning and the end of things.
Well, since we talk about the Big Bang, I kind of feel if you had the Big Bang, that's the beginning, but somehow I feel it's incomplete. Somehow I feel, what was there before Big Bang? I mean, what happened before Big Bang? So, in that sense, what you say to me is more pleasing than knowing something wasn't there, all of a sudden it just started, and was there previous episodes? I would question that.
Yeah, it's really a moot point because whether or not there was something before the Big Bang is really moot because we can't know what we don't know.